Hey, good morning, neighbors. Well, it turns out I can't live stream anymore. So, or from this good camera, and you can see the results in my last video of the PC camera. So somehow I've got to figure this out if I want to go live. But I'm alive, so I'm there. All right. Last video I did yesterday on the fuel in reactors. And I kind of blew the conversation, and it was a terrible video, but you could listen to it, so that was cool. The challenge is this is so big in so many ways, it's hard to figure where to start. And if I get into isotopes and reading those reports, I don't know how valuable that is to folks. And it's a very long study because you have to go through all the reports and compare them one to the other at their time of entry. And you have to know if the data can be compared. Is it the same location data, same instrument type of data? What are they measuring? So it gets pretty complicated to try to do that. You need to use a set of source documents, which, to my understanding, should be owned by the IAEA. All right, and this is part of what they do. And I am absolutely positive that the NRC's defense center that's monitoring all of our nuclear plants in the U.S., or is trying to, that's in Maryland, was built almost a decade ago now, I suppose. So there's places where this information does exist. If it doesn't, it's almost criminal, because these people are responsible for the health and welfare of American citizens. So my opinion on all of this is there is so much data that we don't have access to because it's called military secrets, it's called corporate secrets, they're trade secrets, they are patent secrets, they are not normal patents, they are secret patents, which have a whole different set of rules and priorities around them and do disappear. So, that I know there's no secret free energy patent hidden out there anywhere, because that doesn't exist, it's not real. But there are patents that have a lot to do with how we understand the world around us. So, all right, back to those fuel pools. I struggled trying to pick a specific topic to talk about, but I talked about the release inventories. Those release inventories are a part of the information that would feed into a plume map, because somebody has to. I talked about the plume maps, right? The pretty colors of dispersion of something across the area, even a weathering pattern. Could be considered as a plume map. So I'm using a very generalized term here about visualizations of information. Um, and the software it takes to run those. So we have the fuel in the 3 reactors. We know exactly the constituents. Somebody does. The day those reactors blew up, there are studies and physics and all types of simulations that do these explosion simulations. So boom, that thing happens. Somebody at a federal level signs a PAG, which authorizes funding and breaks open a study door, and off America goes, where our national institutions start to get involved because they've got the supercomputer access to be able to do the analysis to keep our goddamn aircraft carriers out of the plumes. Our aircraft carriers are some of the most heavily instrumented weapons on the planet. I can't believe they missed this one. Total friggin' miss. Sorry, sailors, but hey, I would have been on your boats if I ever sailed. All right, guys. So, boom, plant blows up. We know that fact, right? Blew up over days. So this was a slow motion explosion. It was more akin to massive explosions. Okay, your pressure cooker blew the top off, and now it's just sitting there steaming and boiling and cooking because you can't turn the gas off. So that occurred for 3 days to 6 months to a year, and it decreased over time. Those emissions did. Instruments tracking, measuring this stuff, because this is what we do. Somebody did it, okay? So there we are. There's a bunch of people got a bunch of money to go look at a bunch of stuff very quickly, and try to make assessments to figure out what to do about it. The only problem was they had no idea what to do about it. If you look at the response, the science wasn't ready, the technology wasn't ready, the engineers weren't ready, the equipment wasn't ready. In the 8 years since that accident, they have not yet invented a camera or robot that can truly get near these things. They're getting close now, right? How many years later? How many years after Chernobyl did they not know they needed this kind of equipment? You know, a NASA robot died at Chernobyl. It's part of the artifacts in that graveyard. So, okay. So this is really step 2 to the first step of the reactor content video. I don't intend to do this long. It's 5 minutes now. I might go to 10. And again, to get into specifics is, we can go there. We can go there. You have to have the right questions to ask. And if you figure those questions out, I'm not the person to ask. See, that's the challenge. But, all right. So, initial assessments of the reactor explosion were giving estimates of releases into the atmosphere, which means basically they were swagging, saying 20% of the reactor fuel components released to atmosphere, 80% is still in the vessels. And that could have been true on T1, day one of this event. That might have been the case, that it wasn't as bad. There was an initial huge explosion, which was terrible, and then those releases began, because now all that mess is bubbling. It never has before. Unfortunately, they had to put seawater on there. And if you go look at the chemistry of seawater, the nuclear chemistry effects of seawater, it's chemistry, but chemistry plus. It's like atheism plus. So, yes, nasty stuff. Nasty things happen to those fuel rods. Basically, they're burned. They're never usable again, and they're actually put in a more unstable state than they were in, because of all the minerals and elements that are inside of seawater. Go look at sea salt. Sea salt comes from seawater. Take a look at the list of ingredients in sea salt. That's what got into those reactors. That eats stuff, that salt, that NaCl, NaCl. So it was an undeniable bad choice when there were no others. That's the decisions that you have to make as engineered senior professional kind of person that has people's lives at risk. So you begin to appreciate that as you work through an environment. When you sit next to a reactor making plastic that's 6 stories tall and is designed so the top of it blows off if there is an accident, because if it were to shred the reactor sideways, the shrapnel would be unbelievable. So people know how these reactors work, and that was a low pressure exothermal reactor. It was not nuclear, but we pulled 600 pounds steam off it, so you can do some PV equals NRTs in there and figure out some temperatures being played with. Massively hot reactor. So that's the kind of stuff you work on. When you work on the control systems that are running the thing, you don't make stupid mistakes or decisions in testing things or in figuring out why one thing isn't working when there's an array of 100 it's attached to. Your planes crash when you don't pay attention to these things, especially in software. So Fukushima went boom. Monitoring was turned on. We know that because Obama spoke to this. And in that, he didn't mention his PAG authorizations and who got money out of that, but things like a massive shipment of some of the best, I had it on my mind, boron. The 24 mule thing? Well, boron is a neutron moderator. So if you go look at boron mining and boron contracts, this is big business. This is not your 7-Eleven kind of business. Information on those contracts disappeared around those times, but there was an initial big hit that you could find in the markets. So somebody needed a bunch of boron very quickly, and you can chase the documents out as you please. But that's part of that's when you sign those PAGs, it turns money on, and most of that money in this field goes to national labs, and it goes to contractors to national labs, and it goes to universities. And So the information's there. This is what I kind of tried to say yesterday. I hope this video is better. Um, Again, this is a cumulative. Knowledge is cumulative, just like radioactivity is. And it does have a half-life, because you forget, as you can tell when I stumble on some of these thoughts and theories and my opinions build. So, hey, enjoy. Nice talk over the fence. This was kind of to make up for yesterday's, and I wish I could go live better, but it's not what